Good day, everyone. So today we are going to be talking about indices. If you are talking about indices, we are going to be dealing with numbers with powers. So we have various rules of indices. The first one is multiplication rule, division rule, power rule, product power rule, zero index rule, negative index rule, fractional negative index, root power rules, general root power rules, and exponent rule. So we can refer to as rules of indices or laws of indices. So let's start with the first one, multiplication rule. What is multiplication rule stating? Multiplication rule is stating that if you have two numbers that are the same and they have powers, we can make these two numbers to be one. Then the multiplication will change to addition. So guys, for example, let's say we represent the number as x. If you have x raised to power a multiplied by x raised to power b, so you're going to say that this is the base number, this is the power. These base numbers are the same, so we can make this base number to be 1. Then this multiplication will then change to addition. So this can be written as x raised to power a plus b. The same thing is applicable that if you have something like x raised to power a plus b, it can also be splitted as what? X raised to power a times x raised to power b. So for example, let's say we have 5 raised to power 2 plus 3, then this can also be written as 5 raised to power 2 times 5 raised to power 3. Why also, if you have something like 5 raised to power 2 times 5 raised to power 3, it can also be written as 5 raised to power 2 plus 3. So since we have the same base, it can turn to 1. So we can also split it to be this. The second one is known as division rule. Division rule. Now here, if we have two numbers that has powers and they are connected together with division, and these two numbers are the same, we can make this same base number to be 1. Then it's going to be written as x raised to power a minus b. So what you have to note is that if these two numbers are connected together by multiplication, multiplication changes to addition. But if they are connected together by division, division changes to what? Subtraction. So why also, if we have it like x raised to power a minus b, you can also split it, you can also rewrite it as x raised to power a divided by x raised to power b. For example, let's say we have 5 raised to power 3 over 2. Look at that, 5 raised to power, let me write 5 raised to power 3 minus 2. So 5 raised to power 3 minus 2 can be rewritten as 5 raised to power 3 divided by 5 raised to power 2. Why also, if we have it like 5 raised to power 3 divided by 5 raised to power 2, it can also be rewritten as 5 raised to power 3 minus 2. So that is what division rule is talking about. Now let's move on to the next rule, power rule. Guys, power rule, what power rule is talking about is that, let's say we have an expression in the form x raised to power a b. You are going to see that we have two powers here. Are you there? Then this expression can be written as x raised to power a times b. So at the same time, if you have it as x raised to power a times b, you can also rewrite it as x raised to power a all b. For example, let's say I have x raised to power 2, 3. This can equals to x raised to power 6, because 2 times 3 is equals to what? 6. So, and at the same time, if I have it as x raised to power 6, I can also write it as x raised to power 2 times 3. So that is what power rule is talking about. Now, we also have what they call a product power law. This, let's say we have the expression xy all raised to power a. This a can open the bracket and it returns to x raised to power a, y raised to power a. Y at the same time, x raised to power a, y raised to power a can also be written as xy all raised to power a, provided the powers of these two base, they are the same. So you can write it as this. For example, let's say we have xy all raised to power 2. This can equals to x squared y squared. Why also x squared y squared can be written as xy all raised to power 2. So this is what product power law is talking about, guys. Now let's talk about the zero index law. This is very simple. It is just that anything raised to power 0 is equals to 1. 1 trillion raised to power 0 is 1. Now the next one is negative index rule. Now guys, we're talking about negative index rule, this general form. If you have this, like let's say we have x raised to power minus a. This expression, whenever you have a negative power, you can rewrite it as 1 over x raised to power a. So this minus will change to division. Then the power will become the what? It's going to come to the denominator. Also, if you have 1 over x raised to power a, you can also write it as x raised to power minus a. That is to say, this division can change to minus. So, for example, let's say I have 5 raised to power minus 2. This can be written as 1 over 5 squared. While also, if I have 1 over 5 squared, this can be written as 5 raised to power minus 2. This is what negative index rule is talking about. The next one now is fractional negative index. For example, generally, let's say we have x over y, all raised to power minus 1. This is very simple. Whenever we have a fraction, and that fraction has a negative index, this negative can become positive. But whenever the negative is going to become positive, then this fraction is going to change to its reciprocal. So this simply means that this can be written as, let me change this one to a. This can be written as y over x all raised to power a. This simply means that this and this, they are the same. So, for example, let's say I have x over y all raised to power minus 2. Then I can rewrite it as y over x all raised to power 2. Let's say I have 4 over 2 all raised to power minus 3. Then this can also be written as 2 over 4 all raised to power 3. So whenever you are changing the negative power of a fraction question like this to positive, then you are going to be changing that fraction number to its reciprocal. Do you get that? That is for the fractional index law. And the next one is root power law. Now, guys, for root power law, you have to know that the first case here is that if you have something like root x, it can be written as x raised to power half. While also, x raised to power half can be written as root x. So, this root x can be written as this. So, also, if you have it like this, it can also be written like this. Another one is, let's say we have cube root x. Cube root x can also be written as x raised to power 1 over 3. While also, x raised to power 1 over 3 can also be written as cube root x. Also, if we have it as fourth root x, it can also be written as what? X raised to power 1 over 4. While also, x raised to power 1 over 4 can also be written as fourth root x. So if it is also fifth root x, it can also be written like that. So you have to be used to what? To these guys. Let's go to the next rule, guys. Root power law. This is the general form. Let's say you have a number that has the power to be a over b. Either you can rewrite this type of expression as bit root x raised to power a. This simply means that the base power will come inside the root, while the numerator will be the new power. So, for example, like this, let's say I have x raised to power 2 over 3. This simply means that I can rewrite this expression as, I will just write this root like this. This base, I'm going to put it inside the power, inside the root, then I'll write x squared. So that is what this expression is talking about. While also, this bit root x raised to power a, bit root x raised to power a, can be rewritten as x raised to power a over b. So the power, the original power here, will become the numerator, while the number inside the root will become the what? Denominator. So therefore, I can also rewrite this expression of x squared as x raised to power 2 over 3. Let's look at another example. Let's say I have 8 raised to power 2 over 3. This simply means that I can rewrite it as, I will just draw my square root like this. This denominator, I will put it inside the root. I will then write 8 squared. Do you get that? Why also, this third root 8 squared, I will just write 8 raised to power. The power of this 8 is what? 2 over, then the number inside the root over 3. So that is how to do it, guys. Now, the last thing we are going to talk about now is the exponent rule. Exponents, what does exponent rule mean? Let me give you a general expression. Let's say I have something like 2 raised to power x is equals to 4. Find x. Guys, I have an expression like this. Exponent rule. What you are going to do is that you are going to look for a way in which you are going to rewrite the left-hand side and the right-hand side of the equation, in which they are going to have either the same base or the same power. So if I look at this, I will notice that this 4 can be written as 2 raised to power 2 because 2 raised to power 2 will give me what? 4. So therefore, this expression I will just write it as 2 raised to power x is equals to 2 squared. Then these two can cancel these two. Then my x is equals to what? 2. Let's say I have something like 3 raised to power x is equals to 9. Look at this expression also. I'm going to study this question. I'm going to look at how can I rewrite the other side of the equation so that they're going to have the same base or the same power. I will now notice that this is 9. Then 3 square, that is 3 times 3, will also give me what? 9. So therefore, I will just write this as 3 raised to power x is equals to 3 squared. 3 cancel 3, then and my x is equal to what? 2. So that is how to do this type of what? Exponent questions. So guys, let's look at a few questions that is applicable to what? To rule of indices and how we can apply these rules in solving what? Questions. So guys, in this particular example, the question is that solve for x in this equation that. Now, the first thing we are going to do is that let me rewrite this equation here. 5 raised to power 2x plus 1 minus 2. 5 raised to power x plus 1 plus 5 is equals to 0. Now, step 1. We are going to apply multiplication law. Multiplication rule. We are going to apply multiplication rule. If you remember what multiplication rule states, so if we have two same base numbers that are connected together by multiplication, we can make these two same numbers to be 1, right? Now, this simply means that the expression 5 raised to power 2x plus 1, I can rewrite it as 5 raised to power 2x times 5 raised to power 1. So this is what multiplication law is talking about. That is, if you have something like this, you can split it into this. Because if you have two same base numbers that are connected together by multiplication, these same base numbers can be turned to 1, then the multiplication is going to change to what? Addition. Also, if I have 5 raised to power x plus 1, it can be written as 5 raised to power x times 5 raised to power 1. So this is by using what? Multiplication law. So that is the first thing we are going to do. We are going to split. We are going to use this law to write this. Then, we are not going to rewrite this question as this. You know this expression, 5 raised to power 2x plus 1, it has been splitted into this. Then it's going to be rewritten as 5 raised to power 2x times 5 raised to power 1. Minus 2, open bracket. 5 raised to power x plus 1, this will be written as 5 raised to power x times 5 raised to power 1 plus 5 is equals to 0. So now, once we've written this, you will now note that from power law, this particular expression, 5 raised to power 2x, I can write it as 5 raised to power x all squared times 5 raised to power 1 minus 2. 5 raised to power x times 5 raised to power 1 plus 5 is equals to 0. So, you know, if I use these two to multiply this, I will still get this back. So, the step 2 now is that I will then say let 5 raised to power x to equals to m. If you wish, you can use any letter you want to use, any alphabet. So, this, if I should represent my 5 raised to power x as m, this simply means that this expression here, you know this 5 raised to power x or raised to power 2. So, if I should change this 5 raised to power x to m, then I'm going to get m squared times 5 raised to power 1 minus 2m times 5 raised to power 1 plus 5 is equals to 0. Do you remember this? Don't forget that 5 raised to power s is represented as what? As m. If you wish, you can use p, you can use a, you can use anything. So therefore, this expression will then turns to something like 5m squared minus 2 times 5, 10m plus 5 is equals to 0. So we are going to solve quadratically. So guys, if you solve these equations quadratically, then our m will equals to 1. M equals to 1. So guys, but do not forget that what we are asked to calculate is what? Is x. But what we've gotten is what? Is m. So the step 3 now. The step 3. You will just recall. You are going to recall that f raised to power x is equals to m. You are going to recall that 5 raised to power x is equals to m. So therefore, since our m is equals to 1, this simply means that this expression is going to be written as 5 raised to power x is equals to 1. And guys, don't forget that if you are to use the exponent law, that was explained before, we are going to find a way to express the other side of this equation in order to get the value of x. So what are we going to do now? Is that anything raised to power 0 is going to give us what? 1. This simply means that this can be rewritten as 5 raised to power x is equals to 5 raised to power 0. So the reason why I'm going to be using 5 is because I want to get the value of x. The value of x is power. So I'm going to look for another way in which I can express the other side of the equation. So they are going to have equal base, the same base rather. So this is 1. Then if I write 5 raised to power 0, that is still what? 1. So therefore, x can cancel x. So therefore, the value of x is equals to what? 0. So the x that I was asked to look for is what? Is 0. The answer is 0. So guys, sometimes when you are done with your workings like this, you might want to cross-check if what you've done is correct. Then you have to use this method. Listen very well to this method. You see, whenever you are talking about equality sign, if you say that something is equal to another thing, what we actually mean is that everything that is here must also be here. So if you see that left hand side is equal to right hand side, this simply means that all the values of the left hand side will be the same values for the what? Right hand side. So therefore, since I have this equation 5 raised to power 2x plus 1 minus 2, 5 raised to power x plus 1 plus 5 is equal to 0. When they said I should solve for x. So what they asked me to do is that I should look for a particular value for x, in which if I should substitute this value of x here and I add everything together, I'm going to get 0. But if I substitute any value for x here and I add everything together and I did not get 0, that is what's on this left hand side, that simply means that the value for x that I used is wrong. But if I should substitute a value for x here and I add everything together and I get the value here, which is 0, that simply means that the value of x is what? Is right. So therefore, we want to check if truly the value of x we've gotten here is 0. If truly this value is correct for x. Now, if this value will be correct for x, if I should substitute this value of x, which is 0, into this equation, then it must give me what? What is on this right hand side. So let's check. So I'm going to write this left hand side. So whenever I see x, I'm going to put 0. So I will just say 5 raised to power 2 times 0 plus 1 minus 2. 5 raised to power 0 plus 1 plus 5. So this is what I'm going to do. So if truly the value of x is equal to 0, after I add everything together, I must get this value, which is 0. So what I'm going to do, what is 2 times 0? 0. 0 plus 1, 1. So this one will change to 5 raised to power 1 minus, what is 0 plus 1? 1. Then this is 2 raised to power, 5 raised to power 1. 2 times 5, 10. 5 minus 10 plus 5. So you now see that 5 minus 10 is minus 5. Minus 5 plus 5, that's equals to what? 0. So this simply means cross-check. So since after the substituting of the value of this x into this equation, I get what is on this right-hand side of the equation. That simply means that the value of x I got is what? Is correct. I will then write correct. So that is that, guys. That is that. Now let's go on to the next example. So guys, in this particular example, we are to look for x, right? So what I'm going to do is that write solution. Now, this is the question given to us. Let's first write the question. 5 raised to power x plus 5 raised to power 2 minus x is equals to 26. So guys, look at me. What I'm going to do now is that I'm going to apply the multiplication law. Then this expression is going to be rewritten as 5 raised to power x plus 5 raised to power 2 times 5 raised to power minus x is equals to 26. You know, I will just split this expression as this. So once I split it as this returns to 5 raised to power 2 times 5 raised to power minus x. Do you get that? So that is using what? Multiplication law. The next thing I'm going to do now is that this expression can then be written as 5 raised to power x plus 25 times 1 over 5 raised to power x is equals to 26. Do you remember the negative index? The negative index. So that negative index is going to change to what? Division. So the next thing I'm going to do now, I will just say that let 5 raised to power x is equals to m. You can use any letter if you wish. So this expression, this just turns to m plus 25 times 1 over m is equals to 26. So this expression returns to m plus 25 over m is equals to 26. So I will just say multiply through, or let me say multiply both sides by m. So I'm going to multiply both sides of this equation by m. So m times m, this one returns to m squared plus 25 over m times m. You know, if I write something like this, 25 over m times m, the m will cancel m. So this will remain 25. Then 26 times m, that turns to what? 26m. Then I can write this expression as m squared. I'm going to bring this 26m to the other side. Minus 26m plus 25 is equals to 0. I will then solve this quadratically. Solve quadratically. So guys, after solving quadratically, I'm going to see that my m1 will equals to 25, my m2 would equals to 1. That is after solving quadratically. So once I've done that, the next thing I'm not going to do now is that, don't forget that what we expected to look for is x, not m. I will just say that if 5 raised to power x is equals to m, and my m1 is 25, this expression will just change to 5 raised to power x is equals to 25. Then this will be 5 raised to power x is equals to 5 squared. Then this 5 cancel this 5, my x is equals to 2. Also for this, I will say if 5 raised to power x is equals to m, and my m is 1, that will be 5 raised to power x is equals to 1. This will be 5 raised to power x is equals to 5 raised to power 0. This cancel this, then my x is equals to what? 0. This simply means that the value for x for this expression is what? 2 and what? 0. Guys, don't forget, let us cross check. Now, if truly the value of x is 2, then you know that if I should substitute this value of x, which is 2, into this expression here, I must get what is on the right hand side. If I substitute the value of x to be 2, in the left hand side, I must get the value on the what? Right hand side. So let me check. So you know, if x is equals to 2, this expression will change to 5 raised to power, let me write, cross check. So that will be 5 raised to power 2 plus 5 raised to power 2 minus 2 is equals to, guys, what is 5 raised to power 2? 25. What is 2 minus 2? 0. What is 5 raised to power 0? 1. Anything raised to power 0 is what? 1. This simply means that 25 plus 1, that is what? 26. Therefore, this x is correct. Now, let me check if this second value is also correct. You know, I will also substitute it here. After adding everything, I must get this. So, let me do that. So, that will be 5 raised to power 0 plus 5 raised to power 2 minus 0. So, guys, what is 5 raised to power 0? 1. Then, what is 2 minus 0? 2. Then, what is 5 raised to power 2? 25. Then what is 25 plus 1? That is what? 26. That's also 26. Then this simply means that the value of x is what? Is also correct. Guys, for the sake of those that will be doing CBT exam, indices question, CBT trick. Now, let me tell you something. These questions, if you see it in CBT, computer-based test exam, you don't need to use the add method to solve it. You are only to use add method if you are doing written exam. Now, if you say this type of question in CBT, what can you do? What you can do is very simple. You will just use the trick. The trick is very simple. Now, listen to the trick. The trick is that whenever they ask you to look for a value for x, if the value for x is in any of these options, let's say the value of x is 0. If truly the value of this x will be 0, if I should substitute 0 here into this in the left hand side, I must get the value on the right hand side. But if after I substitute the value of x into this, I did not get the same value as it is on the right hand side, That simply means that the value I use for my x is what? Is wrong. So now let me test if this 0 will be the answer without solving the question. What I will just do is that solution for number 1. So you know this is the expression. I will just substitute the value of 0 here. If after substituting the value of 0 here, I add everything together and it gives me 0. That simply means that my x that I'm looking for is what? 0. So you know that will now be 5 raised to power 2 times 0 plus 1 minus 2. 5 raised to power 0 plus 1 plus 5. So let me add everything together. You will see that if I should add everything together, it's going to give me what? 0. So since after I represent my x as this option A, I add everything together and it gives me the value on the right hand side of the equation. That simply means that option A is correct. Let me test option B. Then you can test option C and option D by yourself and see if they are also correct. So let me test option B. I will just represent my x as 1. That will be 5 raised to power 2 plus 1 minus 2. 5 raised to power 1 plus 1 plus 5. So if truly the value of x is option B, are you there? I must get this 0. But if I don't get this 0, that simply means that the value of x is not option B. So guys, what is 2 times 1? 2. What is 2 plus 1? That is what? 3. Right? So this will now be 5 raised to power 3. Guys, what is 5 raised to power 3? That is what? 75. Minus. Now, what is 5 raised to power 1 plus 1? That is what? 2. Right? Now, what is 2 times 5? That is what? 10. So that will now be minus 10 plus 5. You know we have 5 raised to power 3. 5 times 5 is 25. That will be 25 times 5. What is 5 times 5? 25. That is 5, remember 2. What is 5 times 2? 10. 10 plus 2, that is 12. Sorry, this one should be 125. So guys, you now see that if I should add everything together, this is 125 minus 10. That is what? 115 plus 5. That is what? 120. You see that after I represented my x as 1, the value I got is not the same as the value on the right hand side of the equation. That simply means that option B is wrong. So if you also test option C and option D, they will never give you the value on the what? Right hand side. So option C and option D are also wrong. So you see that I don't need to solve before I can what? I can get my answer. Let's do the second one, guys. So guys, the option question 2 in CBT exam. 5 raised to power x plus 5 raised to power 2 minus x equals 26. Solve for x. This is option A, this is option B, this is option C, this is option D. You know, in this particular question also, you don't also need to write anything. You don't need to solve before you can get your answer, even if you don't know the step you have to take. Now, what I'm going to do now is this. You will just be testing the options one after the other and see the one that's going to give you the value on this right-hand side. Now, let me start with option A. You know, option A is 0. This is 0, 1. So, now, 0. If I should substitute the 0 here, this will be 5 raised to power 0 plus 5 raised to power 2 minus 0. So, guys, what is 5 raised to power 0? 1. What is 2 minus 0? 2. Then, this one will give me 26. This simply means that one of the value for x here is what? Is 0. Then automatically, before you continue, 26. Before you continue, just delete option B and option D. Do you get that? So since you've gotten one of the value for x to be 0, this simply means that in the answer, there must be what? There must be 0. Now, let me test the second value here, which is 1. So let me substitute the value of 1 here. This will be 5 raised to power 1 plus 5 raised to power 2 minus 1. Now, guys, what is 2 minus 1? That is 1. So what is 5 raised to power 1? 5. What is 5 plus 5? 10. So this simply means that if I should represent my x as 1, I'm going to get 10. And 10 is different from 26. That simply means that 1 is not among my answer. So once one answer is wrong, out of these two answers, that option is wrong. So this simply means that automatically option C should be correct. So let me test. You know I've tested 0. 0 is correct, right? Let me test if these two will also be correct. So whatever I see x here, I will just put there. This will be what? 5 raised to power 2 plus 5 raised to power 2 minus 2. Guys, what is 5 raised to power 2? 25. What is 2 minus 2? 0. What is 5 raised to the power 0? 1. Then this will also be what? 26. This simply means that option C is also what? Correct. So guys, that is how to use the option testing method to what? To solve this. You don't even need calculator. You just have to what? To know this trick. Do you get that? So that is that, guys. Thank you for watching. We are going to move on to laws of logarithm in the next video. Thank you.